Welcome back. In this video, we're going to talk about something called vertical angles. So previously, we did a problem that looked like this, an intersection of two lines, and I told you that this angle right here is 120 degrees. What we discovered was that this angle on the right also had to be 60 by linear pairs, right? Where we found the linear pair formed by these two lines, the big line that forms a base and the line in the middle that makes them adjacent, right? But what if I wasn't looking for that line over there? What if instead I was looking for this angle, right? The one across. How would I get there? Well, the key is it's actually a sequence of linear pairs, right? First, I do this linear pair to find the angle that was between them, 60, and then I see that there's actually another linear pair here, this linear pair right here, right? And when I do this, I see, well, the supplement of 60 is, wait a second, we already did that, right? That's how we got 60. It's 120. Remember that the supplement of a supplement is the original number again, right? The supplement of 120 is 60, and the supplement of 60 is 120, right? So what we found is that any sequence of linear pairs, a linear pair then another linear pair, just gets me my original number again. And we can use that again, right? If I was to keep going and say, okay, well, I don't want this one. I want the one across from the 60. That's actually also going to be 60. Because again, it's a linear pair with 120 in two different directions. This special relationship between these side lengths and these angles, right? These segments and these angles form what is called a vertical angle relationship, okay? This is a shorthand. You can always do this by just doing two linear pairs in a row, but it goes a lot quicker when you recognize that vertical angles are non-adjacent angles at an intersection of lines that are congruent. Okay, and remember, congruent here meaning equal angle measures, right? So the non-adjacent ones, the ones across from each other, are congruent to each other. They have to be the same angle value. Now again, if you don't remember this, you can always recreate it with linear pairs. Like if you're on a test and you didn't do any notes, which you should do notes, and you're not watching this video, which you should be watching this video, but if you weren't, right, you would just be able to do this with linear pairs. You don't need to know this, but it goes much faster if you know this, right? A lot of things in math work out that way. We do it the long way once so we can do it the short way in the future just by saying, well, you know to do two linear pairs, so we're just going to call that sequence a vertical angle, right? Where you're just going to, you could do it the other way around, but this is the shorthand for it, okay? Saying insert here all the steps you would do to find this. That's it, right? Now the tricky thing is, again, in a math problem, we're not going to see this necessarily, right? So if I was given a trickier problem like this, and there's three lines here, and they said, okay, this one is 60, find me this angle. I don't need to look at every single line. I only need to look at the two intersecting lines that form a vertical angle relationship to know that this is also going to be 60, right? And I could use that for the other ones too if they gave me any more information. All right, I hope that helps. In the next video, we're going to again apply linear pairs, but also mix in some other stuff to be able to prove something about angles exterior to a triangle. So I look forward to seeing you then.